はい、皆さんこんにちは。サイバーチェック YouTube チャンネルへようこそ。今日はですね、ArrayStacks について説明をさせていただきます。最後までよろしくお願いします。では、動画に行きましょう。はい、ArrayStacks はですね、言ってた通り、アレイを使って実証したスタックです。では、一つずつアレイとスタックについて説明していただきます。まずは、スタック。スタックはですね、last in, first out。日本語では、後入れ、先出しのデータ構造です。つまり、最後に入れたものを一番最初に取り出すことできるデータ構造が後入れ先出し last in first out データ構造です。イメージしやすい例といえば、このお皿の山を見てください。この山に新しいお皿を入れる場合、この山の上に新しいお皿を置きます。この山からお皿を取り出すときも、一番上から、つまり一番最後に入れたお皿を一番最初に取り出します。つまり、このお皿の山は今はスタックです。次はアレイ。日本語では配列。配列はですね、同じ型のデータを連続して並べたものです。例えば、これは数字の配列です。それぞれのデータには、インデックスという番号があります。このインデックスを使って、この番号を、この数字をアクセスできます。例えば、もしこれ、名前は A なら、このインデックスを使って、こちらの数字をアクセスできます。あれはですね、データを素早く取り出したり変更したりできるのが特徴です。ただし、サイズは交代しているので、途中で大きさを変えることができません。最後にアレイスタック。ここまで説明したことをまとめて、アレイを使って実証したスタックがアレイスタックと言います。特徴としてはとても高速でシンプルです。ただし、アレイを使っているので、サイズを交代されています。つまり、アレイスタックのサイズも変わることができません。これから実際に Java でアレイスタックを作っていきましょう。コーディングパートは日本語の字幕と一緒に英語でやっていきたいと思います。Let me discuss a code which is used to create an array stack and how this works. So first of all, I have a class called ArrayStack to create my array stack, and here I use the int as the type of my array. So this array stack can only be made to store numbers, but also I can make this to work with any type using Java generic such as this, and create my array into the type T. But just for now, for this example, I'm going to keep this as an integer array stack. Then I have a variable to store the max size for my array stack, and then I have an variable called top. So what is this top variable? Let's move back to the whiteboard. So as said in the code, this is the temporary array for the stack, and this is the variable to store the max size of that array. And what is this top element or top variable? So when here I have already declared a stack using an array with the size of 5. So there are spaces for 5 elements, and since this is an array, they are all indexed. So the indexes starts from 0 and goes to 4. So what is this top variable? This top variable should show us the head of our stack, which means the last inputted element. So think of this top as a bunny, a very helpful one. So this bunny can hop around these indexes both forward and backwards. So we can use that bunny to show us the head of our stack. So imagine I input 1 and 2 into this array. So the last element I inputted is 2. So the head of our stack is 2. So we can make, if we can make that this top can show the index of the last inputted element, we can easily make this array a stack, since all we have to do is do operations with the last inputted element. So this is the main purpose of the top variable. For now, get this idea as a bunny, and we will continue on the code and see what's happened. So since we now have an idea about top, let me describe the constructor of this class. This is the constructor we use to declare our stack. So we need to obtain a size to store in our max size. This is going to be the capacity of our array stack, and we are declaring our array with this new obtained max size, and I'm equaling this top to -1. What happened then? Let's move back to the whiteboard. What is this top equal -1 actually means? When we declaring the stack, which is done in the constructor, we say the top size, but we don't actually add any elements into the stack. So while declaring the stack, there are no elements within the stack. So why would we make the top equal to -1? So our top's priority is to show the index of our head element. Right now we have no element, so our top is actually in the outside of the stack, which means top is not inside the array. So when we are adding elements, our top can move into the array and show us the head of the stack. That is why we are equaling, or we are putting the top as -1, because we have no elements inside our stack while declaring it. Right now we already declared our array using the size we obtained earlier, and we stored -1 in our top variable. So right now we need to do the pop and push functions. So they need to follow the last in first out principles. Before moving into the code, let's actually describe the logic behind this push function. So let's talk about this push function logic. So what should be happening push is elements should be inserted into our array, which means our stack. So while doing that, we need to keep the track of our last inputted element, because this is a stack and it should follow the last in first out principles. So using the constructor, I declared this array stack called A, which is size of 5. So I have a array built here with the indexes 0 to 4. And my top is equal to -1, which means my top is actually outside of the array. So as I said earlier, this top is like a bunny, and it should hop around these indexes and show us the last inputted element. So when I'm trying to insert or push one into my stack, the one should be entered into the stack, and my top should go to that specific index. Pushing one should be entered into the array, and my top should be already be here. So how do we do this inside Java? So we can of course use the indexes to access the array. So if I use this top equals 1, this is generally how you access the elements inside arrays, but this will bring us an error, because right now my top is at -1. There is no index such as -1, so this will bring an error. If I do this, this is still will bring us an error, because actually first the element will be added, then the top will be go to the 0. This will also bring an error, because my top is at -1, and 1 can't be added to -1 index, because there is no such thing as -1 index. So what we actually need to do is first increment the top, or first tell our bunny to hop once and then enter our element. In this way, my top will go to the 0th index and the elements will be added. Next, I'm going to insert 10 into my stack, and here 10. So my bunny will hop one more to the first index and 10 will be added. Right now, if I ask my bunny where is the head of my element, it will show the place of the head of our element, which is the first index. So likewise, we can add any number or any element. In this case, this is an int stack, so this should be a number. And using this statement, we can actually push the elements into our stack and keep the track of the last inputted element. So is our push function completed? No, because imagine I added many more elements into my stack. So right now I have 5 elements in my stack, which is the max size of my stack. So my bunny actually hopped because of this statement, and it is currently at this 4th index, which is the head of my stack. So right now, if I try to use this push function one more time, my bunny will actually hop once more into a non-existing 5th index and try to add that element. This will always bring an exception because my array is now going out of bounds. So because of that reason, we need to actually check whether the stack is full or not before inserting elements. So how do we do that? It is actually very easy, because the max size is always one more than the max index of the or the highest index of the array. Imagine if this array is actually size of 6, which means we have one more element, and imagine we have an element here, and the highest index of my array is 5th index, and my top is always at its highest index if the array is full. So using this logic, we can actually check whether the array is full or not when the top is same as max size minus 1. So in this case, my max size is 6, and my top is at the 5th index, which means 5. And when 5 equals 6 minus 1, it is 5, which brings us the true, which means my array is actually full. So using this logic, we can check whether our stack is full or not, and then push elements into our stack. Right now we have a logical idea about the push function. So as you can see, we have the isFull function, which is declared later on the class. And if the array stack is full, this will bring us this message, error message. And if it is not full, the element I'm obtaining will push into the array. This is the isFull function, which I described earlier, returning the top equal to max size minus 1. So let's move on to the pop function. As described earlier, let's move on to the whiteboard and check what is this pop function do. So let's talk about this pop function. Pop is popping out elements of a data structure. Since as stack is an last in first out data structure, the lastly inputted element should be popped out first. So here we can already find the top element since thanks to our top variable. And here I have an array of 5 size, which is at max capacity, and my top is in the highest index, which is the 4th index. So while popping, what normally happen in a data structure is removing this top element or head of the stack and showing it out. But right here we are using an array. We can't just remove elements from an array like this. We can't just remove elements. So what we actually can do is change the elements in the respective indexes. So what we should do is simply we can return, or we can print output the current top of our array. So this will bring the last inputted elements in our stack. But also we should decrement the top by 1. So our bunny will hop here. Right now, if I ask my bunny where's the head of my stack, it will show the third index, which means the 12. So this actually doesn't remove this 14 from the array, but it will follow the last in first out principles, because right now if I pop again, the 12 will be popped and 12 will be shown, and this top will be hop backwards into this second index. So you might wonder, because we are moving this top around and not actually removing these elements, when I try to push again, this should bring a array out of bound of exception, because this array is full. No, that is not actually what's happening, because we are actually incrementing the, as you can remember, we are incrementing the current top of our stack. So right now, if I do the pop function once, my top will move from 4th index to 3rd index, and now my top is at 3rd index, but 14 is there. It doesn't matter, because right now the top will move back, or my bunny will hop back again to this 4th index, and it will make the 4th index the element I'm pushing. So example, if I add 24, so this 4th index becomes 24, which means this 14 will replace by 24. So that's what the logic of the array stacks. The elements will not be removed when popping, but they will change according to the last in first out principles using this top variable. So as I said, as we discussed earlier, this is not the complete pop function, because as in the push function, we check the array is full or not. And here we need to actually check the array is empty or not, because if my array is empty, when I'm trying to pop the elements or out of the stack, my top is in the -1th index, and this will bring an error, because we can't return the -1 index of an array. So we need to actually check whether the stack is empty or not before popping the elements. How do we do that? That is very easy, because our top is -1 when the stack is empty. So we can simply create a Boolean function to return whether our top is equal to -1 or not. If this is equal to -1, which means the stack is empty. If it is not, which means stack has elements. We have an idea about what pop function to do, and here I have the function here, which returning an integer, and it is throwing a new runtime exception if the array stack is empty, and if it is not empty, it will return the top element, and it will decrement the top, so that this will ensure the last in first out principles are working. For the peak function, it is same as the pop function, but without this decrement one, since we are only peaking at the top element. This also will throw a new runtime exception, because we can't peak if there are no elements inside our array stack. The isEmpty function, we use for peek and pop function, which I described earlier, simply return top equal to -1. Now we can actually go into a main class and actually test this array stack is working or not. So first let's create an array stack called stack equals new array stack, and we need to define the size. I'm going to put the size as 5, and let's first push some elements. Can push 3 elements like this, some random elements, and then to make sure this is working as a live stack, so we need to pop out element and print it. So if we run this now, as you can see, the 23 is the popped element and it is the lastly inserted element. That means this is working as a stack. Then to make sure the isFull and isEmpty functions are working, we can add 1, 2, 3, 4, 5 and then one more element into the array stack. So this will show us the error message. This should show us the error message, and it is there. Sorry, your array stack is already full. Next, to make sure the isEmpty function working, we can actually push 1 and pop 2 elements out of our array stack. So at first the pushed one should be popped, and then an exception must be caught since there is no elements inside our array stack. So we can see that the array stack is empty. This is a runtime exception. To make sure that the popped elements are changing, so we can actually push another element like 2. When I pop the element, so 2 should be, now the 2 should be popped out of our array, and when I push 3, this 3 should be pushed, or this 2 should be changed into this 3. So we can take this by popping now stack.pop, and as you can see, we have the output 3. So what happened is we first push 1, then push 2, and we pop the 2, and we push 3 again, which means in the actual array this 2 will change into 3, and we then popped it and print. はい、皆さん、これでアレイスタックの基本的な両方とコードの仕組みが分かったと思います。Java での実装も思ったより簡単でしたね。これからもこういうデータストラクチャーの構造も続いていきますので、面白いと思ったらチャンネル登録といいねボタンをお願いします。では次回の動画まで。